What if you could get a perfect fixed 12-volt output from up to 48 volts input using only one MOSFET, one transistor, a Zener diode, and two resistors? No IC regulators, no complicated circuits, just 5 simple components, and the result is a powerful and accurate 12-volt regulator circuit. Let me show you how it works. First, let's look at the components used in this circuit. We only need a few parts: Z44N MOSFET, BC547 transistor, 12-volt Zener diode, two 27K ohm quarter-watt resistors. And that's it. With these simple components, we can build a very powerful fixed 12-volt regulator circuit. First, take the Z44N MOSFET. Before making connections, it is important to understand the pins. If we look at the MOSFET from the front, left to right, first pin is the gate, second pin is the drain, third pin is the source. First connection. Now take the first 27K resistor. Connect this resistor between the MOSFET gate and drain pins. This resistor provides gate bias and feedback control. Now take the BC547 transistor. First understand its pins: collector, base, emitter. Now connect the collector pin of the BC547 transistor to the MOSFET gate pin. Zener diode connection. Next, take the 12-volt Zener diode. Connect the cathode side of the Zener diode to the MOSFET source pin. Then connect the anode side of the Zener diode to the base of the BC547 transistor. Be careful with this connection. If the Zener diode polarity is wrong, the circuit will not work. Second resistor. Now take the second 27K resistor. Connect this resistor between the BC547 transistor emitter and base. And that's it. Our circuit is now complete and ready for testing. Power supply connection. In my case, I am using a 16-volt battery, but you can use any DC supply between 14 volts and 48 volts. Connect. Positive supply to the MOSFET drain pin. Negative supply to the transistor emitter pin. Output connection. Now for the output. We take the positive output from the MOSFET source pin and the negative output directly from the battery negative terminal. Output test. Now let's test the circuit. As you can see on the multimeter screen, we are getting a stable 12-volt output from a 16-volt battery. This shows that the circuit is successfully regulating the voltage. Now I'm connecting another 12-volt battery. And as you can see on the multimeter, the output is still a fixed 12 volts. This proves that the regulation is stable. Power test. Now look at this. The output current is so strong that the wire starts melting. This shows that this circuit is not weak at all. It is a very powerful and accurate voltage regulator. How the circuit works. Now let's quickly understand how this circuit works. The 12-volt Zener diode acts as a voltage reference. When the output voltage tries to go above 12 volts, the Zener diode starts conducting. This activates the BC547 transistor, which then controls the MOSFET gate voltage. The MOSFET automatically adjusts the current flow, keeping the output voltage fixed at 12 volts. This feedback system ensures stable and accurate voltage regulation. This circuit can be used in many applications, such as 12-volt battery charging systems, DIY power supplies, solar projects, automotive electronics, LED lighting systems, electronics testing, power supply. If you enjoy DIY electronics and powerful circuit projects like this, make sure to like the video, comment your questions below, and subscribe to the channel for more amazing electronics projects. See you in the next video.